remind me of those horrible days. Okay. So for reverse bias, we have current is nearly constant but very less for some voltage. Now if you come on this side, the current is nearly constant but very less. It is in microamp, and then suddenly it will shoot up. Up to some point, it is negligible. Right? Up to some point, it is negligible, and then it will suddenly increase. Right? So this point is where we say breakdown. This is what we say is breakdown. Okay. So what is breakdown? In chapter 2 we learned dielectric breakdown. Do you remember that? Dielectric breakdown is when the electric field becomes very strong and the structure breaks. Right? Inside the material, the atoms get a lot of energy, they throw the electron away, right? And this happens because of electric field, right? So strong electric field causes the atoms to lose their electrons. Now, if one electron comes out of one atom, let's say that this is the p-n junction. So if one electron will come out from some atoms somewhere, then that electron, because of the electric field, will accelerate. Make sense? Yes or no? Because of the electric field, that electron which has come out will accelerate. Now, after acceleration, is going to hit other atoms. Collision that. Okay? After acceleration, this electron will hit other atoms. Now, when it hits other atoms, it will give them energy. Because of that, the other atom, it will also lose its electron. Clear? Right? So, the removal of one electron somewhere will have multiplying effect. Clear? The removal of one electron somewhere has multiplying effect. One will hit the other, it will give up electron, then that one will hit some other atom that will give out its electron. So like that, suddenly you get a surge that is a lot of current. One from the other, like that. Okay, so because of this process, there will be high value or larger value of current. That is what happens over here. Understood? Yes, no? Right? Electrons from the atom, they come out, they accelerate, they hit others, same process continues. Okay, so this whole thing is called avalanche. Probably you know what is avalanche. It happens in mountainous regions. Lot of snow, it starts to come down. Once it starts to come down, then it's going to take everything with it and it will keep on increasing. So there is a similar thing here. Once a single electron comes out, a very destructive process is going to start. Okay, so that is what we have for breakdown. So diodes should normally be used only in this region, because if you go beyond that, if you increase the voltage on the negative side actually means reverse. Okay, so current will also flow in reverse direction, that's why this below. Right? But this current is not normally very high, it's only very less, like in microamp. This one was in milliamp, do you remember? Right, we have to measure that in milliamp. Okay, fine everybody. This is called breakdown or breakdown voltage over here, right? This one, right? So that's about reverse bias characteristics of that. Right? Draw the graph, then I'm going to relay it. Continue next. Did I explain button voltage yesterday as well? I did. Like I said, probably that 0.3 voltage for silicon and 0.7 for germanium. I did explain it, right? 0.2. Okay, fine. Okay, so I would have repeated it by mistake if you didn't understand. Yeah. So now let's solve some questions related to circuit, right? Okay. So first of all, we need to get grip of a few important sentences. Is that ideal diode in forward bias is an ideal conductor. Okay, so this is the first important thing to remember when you want to solve diode related circuit problems. Okay, ideal diode in forward bias is ideal conductor. Ideal diode in reverse bias is an ideal insulator. Right? That means it will not allow current to flow at all. Bracket R equal to infinite. Okay, and here R equal to 0. So these are nothing but the cutting voltage. It needs that much voltage to operate. Less than that, it's not going to operate. Mundu thing, okay. I'm so sorry. In other value silicon is 0. Right? Now let's solve question. Frankly, if you remember these four, I don't think you'll have any problems whatsoever with this chapter. Okay. See, this question does look like it's a semiconductor question, but if you look at it carefully, it's mostly current electricity, isn't it? Right? ampere. 5 volt, 10 ohm, 10 ohm is parallel. So that is 5 ohm. Right? So 1 ampere total current going through this battery. And here it will split into half. Correct? So this is going to be 0.5. Fine? Okay, everyone got that, right? So 0.5 ampere is the answer, right? Current in each resistor is 0.5. Call this one. Done. What's the answer? 2 D1 or 2 ampere. And D2 is comma 0. What do you get? First of all, you have to decide how are the diodes biased, forward or reverse. Whatever. First one, D1. Forward bias. Why? Why forward bias? Because positive is connected here and P type is connected to the positive. That's what you get. Okay. What about D2? Reverse. So current will not flow through D2. So if current will not flow through D2, current cannot flow here. Correct? So here I equal to 0. That means there will be no current anywhere. Clear or not clear? There will be no current anywhere. Understood? Okay, so that's going to give you I equal to 0 everywhere. Clear? Okay, now let's come to this next topic. Dynamic resistance. આની વધારે પ્રેક્ટિસ નથી કરાવતા, આવું બધું કરવાનું. Okay. Dynamic resistance. See, in third chapter we learned Ohm's law, which says that R is V by I because V is proportional to I, and that is only true for metal. Correct? So what to do about other things where the VI graph is not a straight line? So for example, it's like this, which is typical for a diode. Dynamic resistance means RD. Delta V by delta. Got it? RD is delta V by delta. Just put that, you get your answer, whatever that is. How do you think about that? So as simple as that. Okay, I'm not going to explain it any further. Right? All you have to do is take two values of voltages, V1, V2, and take corresponding value of current. And if required, draw a chord or a tangent, and then you will get it. Right? So if you are drawing this graph, remember RD is equal to 1 upon slope. I hope you understand why, because this is IV graph, not a VI graph. Mask pero. Okay. So please remember that if you are drawing an IV graph, RD is 1 upon the slope of that. Okay. It could be done anywhere forward, reverse, do I know. solve question based on this. What is the answer? Huh? 1, 400. 400 okay. Hopefully you have just done it the right way. Delta V by delta X. Right? So 4 divided by 10 into 10 raised to minus 6. Otherwise, question for the is the next step. છે બધી વાતો કેમ કરવી પડે? Okay, what's the answer then? Huh? Degree. कैसे करोगे? Look at the slope. So RD is 1 upon the slope of the characteristic curve. Correct? And gradually, as you go towards more voltage, increasing voltage, so the slope will increase. Right? Slope will increase. So dynamic resistance will decrease. Clear? As simple as that. Okay? So answer is B. Now here is your next question. You have to draw, you have to draw the output voltage. Okay, you have to draw the output voltage. This is some resistance. Okay, खाली नो form draw करवाना. Don't worry about any other value, right? Okay, so from here we are giving the signal or input. Here's the diode. When you get +5 here, this diode will become forward bias. Is that clear? Yes or no? Sure? So that if it will become forward bias then, current will. Syntax is one to ideal forward bias diode is conductor. So conductor શું કરે? Allows current to flow. So current will flow. It will flow through this resistance and you will get output. So there will be some current. So you will get some output also. પછી એ રીતે આગળ કરતા જાઓ. So try, come on. Let's say these sections are of t times e, t like that. Okay, do it, come on. You have to draw a graph. Nobody will be lazy. Okay, please do it carefully. Here 0 plus 5 minus 1. 0 plus 5 minus 1. That's it. ગ્રાફ ડ્રો કરવામાં ટાઈમ કાઢ નાખી એવું લાગે છે. ફટાફટ કર. આપણે ભણવા આવીએ છીએ, ટાઈમ પાસ કરવા નથી આવતો. Done? How many of you have finished? Okay. First of all, 0, so no wood. And you take drop back. If you have space, you definitely do it like that. Okay, so for t times 0, then plus 5. So here we will get 5. Okay. So that is next thing. Then third one 0. First thing. Fourth one 0. Fifth one plus 1. Like that it will continue. Understood? Right? When voltage is negative, it will not pass because this diode will become reverse. Clear? So this is how it works. By the way, this is called half wave rectifier. What is it? Half wave rectifier. There the shape is different. That's it. Okay, instead of being squares, it would be like a wave. Okay, it's my same principle. And then related to that, we have the full wave rectifier, right? So, what's the difference between them? A half wave rectifier gives this, then cuts this, then gives this, cuts this. This is half. On the other hand, a full wave rectifier gives this, but is only cycle is okay. It becomes the current flows in the same direction always, right? That's the difference between half wave and full wave rectifier. Okay, this circuit actually alone there, right? But I'm sure now you will be able to understand how it works, right? Simple idea. Whichever diode is forward bias will pass current. Whichever diode is reverse bias will not pass. Right? So there you will see that in the resistance, the current will always flow in same direction. Because flow like that. Okay? So it will always flow in the same direction. That's why you don't get it inverted, you get it in the same. Understood? Right? That's the concept of full wave rectifier. Okay. પછી કઈ નો સમજાય તો પૂછી લેજો એવું કઈ નથી આ તો તમને યાદ કરાવવા માટે જ આ બધું કરાવો. So let's say that this is input form and this input is now given to this kind of circuit. Okay, let's say that this input is now given to this kind of circuit. A and E. And we get output giving the right. So what would be the output voltage? Can you draw that? Input voltage. So what would be output voltage? Can you draw it? Give it a try. Done. You usually complete 1 hour. What's your answer? Then this will behave as a half wave rectifier or full wave rectifier or neither. The only way to decide is to draw output voltage graph. Before that you cannot decide, right? So you'll have to see. So suppose this is positive, this is negative. So here you get positive, here you get negative. So this is going to behave as what? Forward bias. Current will flow. Okay. When you get reverse, what's going to happen? You get it as reverse bias. Diode will be reverse bias. Agree? Right? Diode will be reverse bias. But what about the potential of these 2 points? तो आनी साथे connected છે આની સાથે connected છે. Yes or no? So potential of this point and this point is always same. Potential of this point and this point is also always same. So આ તો કઈ કરતું જ નથી ને. Who understood this? What I am saying is you are worrying about forward reverse, okay, no problem. But ito jo આ point here connected છે. So whatever is the voltage here, the same is the voltage here. Whatever is the voltage here, the same is the voltage here. So જે આ ફોર્મ આવે જે આ ફોર્મ આવે, yes or no? તો આ કઈ કરતું જ નથી. Clear? Okay. So which kind of rectifier is it? Neither. It's not a rectifier. Okay. This is a dummy. समझाए ना? This is a dummy. It's not doing anything. Clear? But yes, by making a few modifications, you can definitely change the circuit. આના બહુ બધા વેરિએશન છે. આ સૌથી easy variation, right? So if you change a few things here and there, things will change completely. Suppose this is just like that. But now instead of A and B, we take C and D, right? And we take output between these 2 points. Okay, I know the diagram is a little bit crowded, but I hope you understood what I've drawn. Okay, between these 2 points here we get output, and here is a resistor, then a load resistance here, correct? Now what do you think this is? What do you think? Sorry? There is no way to guess it. Draw a diagram, draw the graph, you will understand what it is. Is it done? Sure. Your answer. Nothing. Zero. કઈ આવે જ નહીં. It is a balanced Wheatstone bridge. It is a balanced Wheatstone bridge. જો કેવી રીતે થાય છે? Suppose you think of current flowing here. Now I/2 will go here and I/2 will go here. Right? Now that current will come over here and here. Is there symmetry in the circuit? બરાબર ને? આમ બે સાઈડ સેમ જ છે કે નહીં? તો હવે જેટલો કરંટ આમ ફ્લો થશે એટલો જ આમ ફ્લો થશે. How much current in the resistor? ગમે તે હોય ગીરો જ આવે. Understood? Yes or no? Sure? તો આનો ગ્રાફ કેવો હશે? Flat. Clear? Okay. ચલો હજી કંઈક બધું ડરી ન જતા. Okay. Now give it a try. If we take output between these 2 points. ફરી વાર You just have to check current pathways. That's it. Right? પહેલા આને પોઝિટિવ બનાવો અને નેગેટિવ પછી કરંટ ક્યાં ફ્લો થાય એ જોતા જાઓ. Which diode is forward bias? આને નંબર આપી દો. It will be easy to talk about. D1, D2, D3, D4. Which diode will be forward bias? Which will be reverse bias? D1 and D1 is forward bias. Who understands that? Very good. Okay. Then what about D2? D3? Sure. D4? Forward. Clear? So can current flow? No, cannot flow anywhere. No current anywhere. Current will flow like this. From here it will go here, correct? Then it will come here. Then will cannot go here. It will go over here. Then obviously wouldn't go back. It will go over here, right? So we get current. Isn't it? The output I will get. Yes or no? Okay. So this is the first half cycle. એમાં આવે જાવ. Okay. તો અડધું ડ્રો બનાવો. પછી હવે સેકન્ડ હાફ સાયકલ વિચારો જાતે. What will happen when this voltage is reversed? Will current will flow? But the key question is, will it flow in the same direction or opposite direction? So now if this is negative and this is positive, which diode is forward bias, which diode is reverse bias? D3 forward bias, D4 reverse bias. Okay. Pachi D1 reverse bias, D2. Okay, so current will flow from here to here to here. Pachi to that. Then it will go through D3. Okay, then resistance. Okay, is it in the same direction as it was earlier? એમાં જતો ને લેફ્ટ ટુ રાઈટ જ આવ્યું કે નહીં? યસ. So from here now it will go to D2 and come back. અહીંયા ભલે ઊંધો હોય, but in the resistor it flows in the same direction. So હવે અહીંયા શું ડ્રો કરું? કેવી રીતે ડ્રો કરું? નીચે ડ્રો કરું? એમ ન કરાય ને, because the direction of the voltage or the current is still the same. Understood? So what is this? Very cover. Okay, you could get a further question. Suppose they say that the frequency of this source is 50 Hz. Then what will be the frequency of output? If frequency of this source is 50 Hz, what will be frequency of output? 100. Look at the graph. These graphs, one cycle starts all the way till here, correct? Now this graph, one cycle starts ends here. What is the meaning of a cycle? Periodic motion or periodicity that gets repeated. Correct? Sure. So this part. Now second, third. So do you agree that if this takes, let's say, 1 second, then here one cycle will only take half second. How many of you got that? અહીંયા 1 second થાય ને અને અહીંયા ખાલી half. Sure. So frequency has got doubled. So અહીંયા 50 Hz. તો આમાં શું આવશે? Yeah, there is a principle. So in a full wave rectifier, the output frequency is double of input. Don't forget that. Okay. ચલો એટલું થઈ ગયું? સમજાઈ ગયું બરાબર? આવી ટાઈપનો હોય તો ડરી ન જતા હોય, બધું કરી નાખજો. Like we have done it today. Right? questions here? 1 and 2. First one is easy, find current in circuit. See, here it is not given that this diode is ideal, but it is mentioned that it's a germanium diode. So what is that sentence? For a germanium diode in forward bias, what will happen? There will be a voltage drop. Read those sentences. There will be a voltage drop of how much? 0.2. Okay, so do that. Okay, so here there will be a potential drop of 0.2 volt. Now you try to find current in the circuit. What is the equivalent resistance of the circuit? What is the equivalent resistance of the circuit? 9 ohm. Obviously, yes, that's right. 9 ohm is the resistance. Okay. Now what next? This germanium diode is going to consume or draw how much voltage? 0.2. Actually, તમારી બુકમાં 0.2 લેખો છે, બાકી બધે તો 0.3 જ લેશો. Anyway, you can take 0.2, no problem. Right? So here, if it is 0.2 volt, so how much is remaining for others? How much is remaining for others? 11.8. Is it clear? So that is the voltage now, which is available for resistors, and resistance is given. Find out the current. Come on. In second question, you have to use Kirchhoff's law. Are you answered current law? It's going to be 11.8 divided by 9. Clear? So that is going to be 1.3. And then you have already 1. Yeah, 1.31 amp. Okay? This is ampere absolute. Right? So that much current is flowing here in this direction. Now let's go to the second one. The first part is done. Second one. If potentiality is 0 volt, how much is the potential here? 0. Verify what's the potential at B. Right? So we will use Kirchhoff's law, or even frankly, it's not even Kirchhoff's law. I say this is common sense, right? But whether that sense or that intuition has been developed in your mind, I don't know. Right? See, this is how we would be doing it. You go from B to A. Here in resistor, voltage will drop. There will be a decrease in voltage. Correct? Similarly, in germanium diode, there is a decrease in voltage. So if you find out how much is the decrease in voltage, you can actually find out VB. Correct? Okay. It's like saying that I climbed down some distance. Okay, some height. Okay, and now I have reached 10 meter height from ground. Okay, I climbed down some height, let's say I climbed down 20 meters and I reached 10 meters after climbing down 20 meters. Okay, then what would be my original height? How much? 30 meters. Clear or not clear? So finally you get to 0. And here you get drop, here you get drop, and you get 0. So how much will be initial? You can find it easily. Correct? law ne Kirchhoff's law કહેવાય. મેં તમને ત્યારે સમજાવ્યું હતું યાદ હોય. Right? The name is, I mean, it's unbelievable. It's like saying that if you step down 1 meter, your height will decrease by 1 meter. Yeah, that's Kirchhoff's law. चलो करो तो. The other way to do it for people who are not so comfortable is as follows. Do you remember that when we use Kirchhoff's loop law, we write all the minus IR and plus epsilon and etc. Correct? Okay, I am assuming you know that. Without knowing that, it won't be possible. So we used to write 0 always. Am I right? I told you that when we come back to the same point, we write 0. But what if we don't come back to the same point? Like here. Suppose we go from B to A. We don't come back to the same point. Then you can always write final voltage, final potential minus initial potential instead of writing that 0. Baki both do the same. Clear? Everything else stays the same. All the rules. The only difference is instead of putting 0, you write final potential minus initial. Clear? So it's like minus IR. Okay. I have answer or no? What's the answer? Sorry? 7.88. You got it here? 7.8. 8 point something. Same answer. 9.06. Anyone else got the answer? Let me say. Let me do it now. Okay. So starting all the way from here. First of all, you go through resistor. 6 ohm resistor, this much current, so voltage will drop by 7.86. Alright? Here the 7.86 niche utri. Then here in germanium diode, you go down by 0.2 volt. Correct? You go down by 0.2 volt. Okay or not okay? So, how much in all? 8.06. Clear? So finally you get 0. So if you get 0 here, this must be 8.06. Agreed? So it's 8.06 minus 0 is giving you 8.06. That's it. Either side. Okay? Right? Better. Hope that.